For the past few years, AI has been highly intelligent but fundamentally passive. Humans remained the primary bottleneck, responsible for writing the prompts, waiting for the results, and manually executing the output. If a child falls into a duck pond 30 minutes before a wedding, asking a traditional chatbot for help provides a list of clothing stores. Shift in this dynamic. The technology has progressed from simply understanding a query to autonomously taking over the execution of the task. Autonomy has replaced reactivity. The focus has moved from managing a digital conversation to overseeing a system that executes tasks independently. True autonomy requires a system that understands physical reality. It must process sights, sounds, and the laws of physics with the same intuition as a human, rather than just processing text. Gemini Omni achieves this by simulating kinetic energy and gravity from text. When asked to explain protein folding, it generates a physically accurate claymation that shows exactly how the three-dimensional structures interlock. This world understanding enables agentic coding within Google Search. Instead of returning a static text response, the system writes and executes code on the fly to build custom, interactive experiences. In an astrophysics query, Search dynamically builds a 3D simulation of gravitational waves. The student can interact with the orbital objects, seeing how real-time changes in physics alter the visual output. Translating abstract concepts into real-time physical simulations is the prerequisite for an AI to interact with the real world safely and accurately. The back-end infrastructure supporting this autonomy is the Antigravity 2.0 framework. It uses dedicated virtual machines on Google Cloud to power personal agents like Gemini Spark. Because the compute is handled externally, users no longer need to structure their input. A rambling voice brain dump of daily goals, like ordering coffee while coordinating a block party, is now sufficient. The anti-gravity framework parses unstructured audio, fractures it into separate, distinct tasks, and routes them to specialized subagents. These operate 24/7 on Google Cloud VMs, working through long-running tasks in the background, scanning the web, monitoring calendars, and communicating with third-party tools. This allows a user to issue a complex command and then physically close their laptop, knowing the agent will continue the work without human supervision. Google's objective is a product that functions as an invisible digital proxy, managing decision-making and task execution while the user is elsewhere. These agents are moving beyond the browser to embed themselves directly into hardware and system-level operations. On macOS, an agent can observe files selected in a Finder window, such as dog medical records, and automatically draft a friendly boarding request email based on those specific documents. This integration extends to the physical world through Google Audio Glasses, which serve as an ambient heads-up interface. During a live demonstration, the glasses used real-time camera data to identify a cafe the user was looking at, providing the agent with immediate physical context. When the user requested her usual order, the agent opened the DoorDash app, navigated the hidden UI, placed the order, and added a tip, all while the phone remained in her pocket. When AI can process visual surroundings and trigger external applications without user input, the traditional operating system begins to recede into the background. This level of digital autonomy carries significant security implications. A world of independent agents requires a robust framework for verifying the origin of all content. Google is deploying SynthID watermarking and AI-driven security agents like CodeMender to provide the necessary guardrails, automatically patching vulnerabilities in codebases to protect the agentic ecosystem. These consumer applications are the testing grounds for a broader architectural shift. Google is investing in a system that can plan and execute independently, because these same agents are being applied to massive macro challenges. The same framework used to organize a personal calendar is being applied to Alpha Earth, a digital twin of the planet used to simulate deforestation and model solutions for global food security. At Isomorphic Labs, agents are simulating molecular interactions to find potential treatments for immune disorders and cancer, performing research at a scale impossible for manual modeling. The combination of real-world physics, autonomous planning, and global-scale execution signals a shift toward a unified architecture. This keynote demonstrates that the tools once used for digital convenience are being scaled into a general-purpose system designed to address the most complex scientific challenges humanity faces.
Thank you. Share and subscribe to Learn AI for more AI insights.